we're going to start our notes the same way we've always started our notes. I want to see if you guys in class here can write out all of the steps to factoring without looking back in your notes at all. See if you've memorized it by now. It's okay if you haven't memorized it by now, but see if you have. Again, see if you can do it without looking back. And it's not a big deal if you can't, but we should be getting there. Again, this is something like if you don't have these steps memorized, like you're kind of doomed. So hopefully you're going to have them memorized. Yes, the order matters. This is like going to be the order that you should be thinking of it. How'd it go? You guys starting to know it now? After a week of writing the same thing every day? We're going to write it again. We got to move on. If you don't have it, this is it. So the first thing you should always think about when you're factoring is common factors. And then we're going to do the special ones. Next is cross products. Oh, grouping, I forgot. Do you guys remember? How do you know it's grouping? If there's 4 terms. And then we love factoring so much because you can repeat the process. When we take our quiz this week, we're just going to focus on these. And the quiz will be a little bit easier because it'll be broken up into sections. So there'll be sections. One section will say factor using common factors. One will say factor the special factors. One will say factor with using cross products. So it'll be divided up for you on the quiz. It will not be divided up for you when we get to the test. When we get to the test, it's just going to say factor, and you're going to have to figure it out. But we're not there yet, so that's why it's going in kind of chunks like that. The next thing you guys might notice is that normally when I do notes like this, we normally like go in the order that I list them out, right? You guys notice that? And then this time we didn't go in the order that I listed them out. There's a reason for it. This special factors. Really, you could do these special factors the same way we do cross products. You could actually teach this without this step in there at all. Like you could just say this doesn't even exist, and you could do everything with cross products. But what's good for us to understand is that there's these patterns that come up that are super predictable and easy for us to figure out. And we want to save time if possible. Remember where we're going with this. In chapter 9, we're going to be solving quadratic equations, solving equations with exponents. And one of the steps, there's like 6 steps. I forget how many we list out, but there's like 6 steps to solving equations with exponents. And one of those steps is factor, is all of this stuff. So if we could factor quickly, it's going to make it easier for us to do all the other steps, right? That makes sense. If it takes you 10 minutes to factor, well, now that 1 6-step thing is just going to take you, an hour to do one problem. We want to be able to go through it quickly. So, all right. That takes us to today. We're going to talk about special factors. We have already talked about these special factors in our bell work. We are doing the backwards version of these, of numbers 4 and 5. The backwards version of a difference of squares and the sum of squares. So the first thing I want to do is to help us identify each one of them. So we'll start with difference of squares. First off, this term squares. We're not talking about the geometric shape. A square is a term that has a whole number square root. That's when we talk about a square. So examples of squares would be like 49, 64, 9, 225. Other examples would be any even exponent. Right here, let's talk about some examples. X squared, right? Because the square root of x squared is x, right? X to the fourth. What's the square root of x to the fourth? X squared. Okay, let's try this next one. X to the sixth. You might think 6 isn't a perfect square. It is in the strange land of exponents. What's the square root of 6 in exponent land? Yeah, x to the third, right? So any even exponent. So if I had x to the 84th, is that a perfect square? Yeah, 42 and 42. You get the idea. And then, so it's any even exponent. And then you guys know the numbers, right? Like 1, 4, 9, 16, and I'll just put dots, right? All of those are perfect squares, like 1 times 1, 2 times 2, 3 times 3, 4 times 4, and it goes on forever. The word difference. What does difference mean in math? You guys should know this. Subtraction. So a difference of squares is when you have two terms that are subtracted. So x squared is a perfect square minus subtraction, the difference, right? And then another square, 25. You should look at that and go, ah, that's a difference of squares. And then you should be able to factor it in an instant. You just take the square root of each one, and you know that it's going to be 1 plus and 1 minus. What's the square root of x squared? X and x. What's the square root of 25? 5 and 5. That's it. Here, let's try another one. Let's get crazy here. Let's get as crazy as it could possibly be. 100 x squared minus 81. First off, is it a difference of squares? Is 100 a perfect square? Is x squared a perfect square? Is 81 a perfect square? Is it a subtraction? That's a difference of squares. So the square root of 100x squared. No, not 50. 10x, it's a common mistake, right? Because you're thinking of like the exponents. 10x and 10x. Square root, and then plus and minus. Square root of 81. 9. That's it. Factored out, done. Now, let's talk about the long way of doing a difference of squares. The long way is saying that you could actually do this using cross products. And let me show you. We'll go back to this, x squared minus 25. Really, x squared minus 25 is like this. X squared plus 0x minus 25. And then we can go through and do cross products like we've already done, right? What are factors of x squared? X and x. What are factors of negative 25? Yeah, positive 5 and negative 5. And then when we do the cross products, look, plus 5x, minus 5x, 0x, 0 makes 0. We've got it. But here's the thing. We want to save the time. We don't want to do all of that if we can instantly get the answer. I want you to not have to show your work on some of these, because you would just say, if I asked you, well, how did you get that answer? right? Instead of like showing you where I say, well, how did you know that's the answer? You'd say, that's a difference of squares. Watch, it's the same thing with this other one. The 100x squared minus 81. You could have this. 100x squared minus 81 is really like 100x squared plus 0x minus 81. You guys don't need to write this out. I think you guys get the idea, right? Factors of 100 would be 10x and 10x. Factors of 81 would be plus 9 and minus 9. The middle terms would be plus 90x, minus 90x, 0x. See, the middle term is 0. So you could, in theory, like I could have gone through and not taught you about this difference of squares. But I want you to be able to look at it so you can factor things very fast. We good with that? That should be pretty easy to do. So a difference of squares, you know, 1 plus, 1 minus. The square root of the first one is the first. The square root of the last one is the last. That's it. When you do this, it's okay. I would like, how do I put this? It will benefit you to write the plus sign first and the minus sign second. You won't see that benefit until we do it next week, but just get into that habit. There's nothing wrong about writing x minus 5 than x plus 5. I'm just telling you, when we get to the multiple step factoring, it'll be easier for you to keep things in order if you put the minus second. So I've just done it long enough to know it's easier to always do plus then minus. Easy enough? Difference of squares, done. The sum of squares, same thing. Here's the thing with the sum of squares, though. It's harder for students to recognize that it's a sum of squares. Like, that's a very normal thing that students might not know. Like, oh, that's a sum of squares, and get it right away. The way that you know it's a sum of squares, right, is if you take the square. This is like, even the explanation I get can be confusing. What's the square root of 9? 3. And then what's 3 times 2? So see, that, and then you know it's a sum of squares, right? But if you like, that's too much for a lot of people to think about. Even me, when I factor it, if I like just have a thing that I need to factor, I don't necessarily go to that first. Let me help you with this. If a number is a perfect square, like 9, 16, 25, when you're guessing doing cross products, always make the first guess the square root of that number. It might be something else, but it's best to guess the square root first. You'll get it right 95% of the time. If they're putting a number that's a perfect square, usually it's the square root. Not always, but usually, right? So like, let's just say you didn't recognize that it's a sum of squares. A bad first guess would be x, 9, and 1. That's a bad first guess. Make your first guess the square root of it. X plus 3, x plus 3, and then normally it's good to still check, but then we'll talk about the cool way to write your answer. X plus 3 and then x plus 3. You could do that, though, cool kids, and the way I will encourage you to write it is x plus 3 squared, right? Because there's 2 of them. So like this next one. 9x squared minus 24x plus 16. How would we know that this is a sum of squares? Well, I'll explain it to you, and many of you are going to tune out in the middle of my explanation because it's confusing. Let's see if we can get this. What's the square root of 16? What's the square root of 9? 4 times 3. And then what's 12 times 2? So it's the square root of first and the square root of last multiplied together times 2. If that makes the middle number, then you know it's a sum of squares. Great news. You do not need to memorize what I just told you. If you recognize that pattern and like it makes sense to you what I just said and you like pick it up easily, like God bless you, that's fantastic. It's best though to just think, okay, maybe you don't recognize that this is a sum of squares. Your first guess for 9 should always be what? 3x and 3x. Your first guess for 16 should always be 4 and 4. And then you would know it's a minus and minus because of the signs, right? And then you would go through and do this negative 12x minus 12x. Oh, look, it's negative 24x. See how you can like not necessarily know if it's a sum of squares, right? You wouldn't like, you could just make your first guess the square roots. Here, let me give you guys another one. And let's see, you figure out, tell me, is it a sum of squares or not? See how it's difficult to identify? Right, you guys get what I'm saying here? It's not like it just jumps out at the page at you. Is that a sum of squares? Well, let's try to figure this out. What's the square root of 100? 10. What's the square root of 16? What's 10 times 4? What's 40 times 2? Is that a sum of squares? No, you have to start. But see, like, that's way too hard. Like, no one sat there. It doesn't jump out. Here, watch how much easier this is. Is this a difference of squares? Is that a difference of squares? That is not a difference of squares. There's many reasons why it's not a difference of squares. Is 30 a perfect square? No. Is this a difference? You should know that's not a difference of squares. Here, I'll try another one. I'll put it up there. You should tell me, is it a difference of squares or not? X squared minus 11x. Is that a difference of squares? How do you know? 11 is not a perfect square. See how easily you can come up and go, oh, that's a different. This is a difference of squares, or it's not a difference of squares. That's easy. The sum of squares is much more difficult to figure out. So if, again, you notice the pattern and you can figure out the sum of squares on your own, that's fantastic. If not, then just take the square root of the first and the last term to make it your first guess. This is what's going to happen on your work. And this is where it gets a little bit more important. I'm not doing it from the book because I don't like the way the book does this. The first section, I'm telling you it's a difference of squares. That should be easy because you know it's a difference of squares. Like, we can just like slam out all the answers right now. Like r plus 7, r minus 7, s plus 9, s minus 9, s plus 6, s minus 6. See how fast you could, like, you should be able to factor those in an instant because you know they're a difference of squares. Same thing with the sum of squares. We should be able to factor those instantly, right? D plus 9, D plus 9, D plus 2, D plus 2, because we know it's a difference of squares. In the book, the whole section just tells you automatically what they are, and you'll like finish the assignment in like 2 seconds. But the next part, now you're going to have, it's mixed together. Some of them are just regular cross products. Some of them are the special ones. So if you get to a special one, you should be able to go, oh, I don't need to do the cross products. I know that's a difference of squares. I can factor this one quickly. Or you go like this first one, that's not a special one. I've got to go through and do all my cross products guesses. All right. So it's important not just to be able to do a difference of squares or the sum of squares. It's important to identify when they are so you can save time factoring. One last reminder, if none of this made sense, then just do cross products every single time, right? If you have something with 2 terms and this whole difference of squares things doesn't make sense to you, it will eventually. Just turn the middle term into 0x and factor it with cross products. You'll still get the right answer.